there's another subject matter which is very closely related to this, okay? And you should keep this in mind, and that's the holographic universe. Holographic universe is something invented by especially the string theorists, because you're asking a question. You're saying, look, I want to know. All I want to know is why this pencil falls downwards. What causes gravity? What causes this pencil to fall downwards? That's the only question I want. A very simple question. You have an astronaut. He's flying to Earth. What's the system? Astronaut, Earth. That's the whole system. Very simple. It's baby stuff. It's kindergarten stuff. Do we need any math? Of course not. We don't need any math whatsoever. I want to know the cause. What causes the astronaut to fall to Earth? Or why doesn't the moon fly out of the solar system? What keeps it bound? What keeps it faithful to the Earth? Very simple question. Straightforward. And these people say, well, let me tell you about a black hole. It's got a singularity in the center, and at a certain radius you'll find the event horizon, and all the matter that has fallen into the black hole, which apparently goes at the speed of light to the singularity, but somehow they preserve it in the body of the black hole, in other words, between the singularity and the event horizon. It's held there, and it's mapped onto the surface of this globular thing that encapsulates the singularity, known as the event horizon. And that's known as the holographic theory or hypothesis, whatever they want to call it. And they extrapolate that and they say, look, the universe itself, our universe, right, is a hologram. And all the physical objects like planets, stars, atoms, gases, whatever, right, is mapped onto the surface of this ball, the event horizon of the universe, because I guess we live in some kind of black hole, right? And all this matter is somehow, instead of being spat out by Big Bang, I guess is falling to a singularity, which is where we started at the Big Bang, right? I don't know, which direction we're going. But the point is, it's mapped onto the surface of the event horizon of the universe. That's the notion these people have. And it's very much related to this other nonsense, the simulation theory. These people have lost their minds completely. They're no longer, with their feet on the ground. These are irrational individuals. And here you have a picture, famous picture that's out there about the holographic universe. It looks more or less like that. Again, this is just the Earth, but think of the Earth that you see there as the whole universe, right? Some kind of ball, Big Bang exploding, right? And it can be mapped onto a two-dimensional surface of some kind. That's what they're saying. And what's being mapped? The information. Information. They're mapping information. What does the word information have to do with physics? Are we going to move information? Are we going to transfer information? In physics, it's very simple, or science, really. Science is very simple. You don't transfer information, okay? It's irrational to say you're going to transfer information, that you're going to transfer energy, that you're going to vibrate a field, that you're going to bend time. All those are irrational statements. And no, it's not semantic, it's not word salad. They're doing word salad, okay? Whenever they give you a theory that says that time is warped, or that they transferred energy, or they vibrated the field, they're giving you an irrational explanation. Okay? And so what's the issue? Well, the issue is here you have the this information, and they say they transfer information. You can't. Information is always on the receiving end. What the guy sends is the Morse code. He sends a signal through a wire, right? And that signal is transformed into some kind of dot. And the guy on the receiving end, for him, it's information. He says, oh, SOS, he needs help. So information is what the receiver gets. And he doesn't get it. He just analyzes what the machine translated. But you don't send information. Okay? But these people are talking about sending information and mapping information onto a two-dimensional surface, whatever that means. What information? What are we talking about? Okay, and here we start with this fellow. His name is Matt O'Dowd. He's what is it on PBS? I call it BS. I leave out the P. I don't think it's necessary. It's just BS. And one of the things that Matt O'Dowd does, he starts talking about this, but he starts out on the wrong foot. And again, it shows the importance of defining terminology. What the hell are you talking about? And here he starts his presentation by defining what dimension is, what a dimension is. And he misses the mark altogether. It shows that he's not a physicist. He never studied physics in his life. And so listen to him make a fool of himself trying to define what a dimension is.
We live in a universe with 3 dimensions of space and 1 of time. Up, down, left, right, forward, back, and past and future. 3 plus 1 dimensions. What is a dimension but a number line of possible values which A, exists alongside the other dimensions but is independent of them, B, over which the rules of physics stay the same, and C, imposes some kind of locality. For example, elements of that number line need to be next to each other to interact. Crudely, this is how an extra dimension can be coded in a holographic universe.
Okay, so you got one right. They're not talking about dimensions, they're talking about number lines. But, he needs to learn the basics. I mean, front and back, left, right, down, those are not dimensions. Those are motions, and or locations. And they have nothing to do with dimensions at all. Here are the dimensions for him to understand, okay? The dimensions are 3, and there are only 3, and it's length, width, and height. Okay, you're not talking about coordinates, you're talking about longitude, altitude, and latitude. And if you're talking about vectors, you're talking about depth, breadth, and elevation. Why? Because vectors deal with motion, coordinates with location, dimensions with orientation, and how you face, right? So all this are basic things that we learned our first day of physics. And this fellow talks about up, down, left, right, motions forward and backwards, and past and future, whatever that is, okay? So no, none of that has anything to do with physics or with dimensions. That's one issue. The other issue is that he did pick one, which hit one right on the nose, which is that, in math, all they have is number lines, okay? And number lines have magnitude but have no direction. They always put an arrow. It comes from this bean brain. His name was René Descartes. And he put an arrow at the end of number lines, and he called them dimensions or coordinates or whatever. In fact, they're known as Descartes coordinate system, right? No, they're not coordinates, okay? They're number lines, and you have to put numbers there, and numbers never have location. They can go in any order you want. You can put a number behind you, another one in front of you, another one to the side. Numbers don't have location, so you can't put them on a line with an arrow at the end of it and say, oh, numbers go in that direction. The fact that numbers increase in a given direction does not mean that they have direction. Direction has nothing to do with increasing numbers, okay? Increasing magnitudes. And so that's where they got confused, or they put it in there by hand. They said, look, numbers increase in that direction. No, they don't increase in that direction, or in that direction. Numbers increase in, the increase in numbers has nothing to do with direction. Okay, that's the first point. Okay, and so, this fellow just screwed that one up, and again, it's because they don't define their terms. Okay, but he continues, and he talks about the information paradox, which is going to be the first step in defining, this holographic universe. And here it is. Listen it from the horse's mouth. Here it is.
Stephen Hawking confirmed the Bekenstein bound by calculating the amount of information leaked by a black hole as it evaporates in Hawking radiation. His discovery of Hawking radiation led to the black hole information paradox, because this radiation was expected to erase the quantum information of everything that fell into the black hole. but destroying quantum information would break the foundations of quantum mechanics, hence the paradox. This conundrum inspired Gerard 't Hooft to show that the information of all material that fell into the black hole could be imprinted on that outgoing Hawking radiation. And while it's waiting to be radiated, that information should be encoded on the event horizon of the black hole.
So these bean brains, what are they doing? They're talking about information now. And what information? And they say the information's encoded on the inside, or I guess on the outside of the event horizon. It's on the surface of the event horizon. It's part of the event horizon. And they start talking about this idiotic thing that Hawking invented, which is that, one particle falls in, the other one falls out, because quantum mechanics says that all particles have their opposite particles, and you have all these virtual particles, they break in two, one goes in, the other one goes out, and that's the one that comes out. And that's how they explain Hawking radiation, meaning comes out. And so this notion that originated the black hole, that, it doesn't emit light at all, they had to remove that because there was no work then for an astronomer to do. It says, well, I can't see a black hole because nothing comes out of it. They said, hey, yes, it does, all this Hawking radiation. But then they said, oh, hold it, but the Hawking radiation, if it comes out, that means you have all this information that's being crushed and disappears forever, and that destroys the second law of thermodynamics, so we can't do that, conservation of energy, all this other nonsense. And so what they said, look, we have an explanation for that, and that is that it doesn't come out with the Hawking radiation, it gets imprinted on the event horizon itself. That's how they figure this out. This is how they reasoned it out, all these people who you're paying their salaries to, to figure all this important stuff out. Okay, and here's how he explains it in a little more detail, how it's mapped on the 2D surface known as the event horizon. O'Dowd, okay, so here it is.
Nice solution, but new paradox. Things that fall into a black hole do actually experience crossing the event horizon and being inside the black hole. So the interior of the black hole has a dual existence. From the point of view of outside observers, its contents are smeared into 2D on that surface, but from the POV of anyone falling in, they are definitely inside the black hole, plummeting to their doom in full 3D glory. This is the first glimpse of a holographic spacetime, a 2D surface that encodes the properties of the 3D interior. 't Hooft, along with Witten and Susskind, extrapolated this to propose that not only is any surface sufficient to describe the locations of all particles in its volume, but also the full machinery of that volume can exist on the surface.
Okay, so all the information, whatever information is, right, is encoded on the surface of the black hole. What's this got to do with physics? What's it got to do with anything? Assuming it's true, we're going to concede, right? What's it got to do with physics? Are we supposed to look at a black hole event horizon and figure out that whatever fell in? What is this information thingy that they're talking about? And the thing here is that Susskind got into a little war with Stephen Hawking on the issue, and he wrote a book, The Black Hole War, My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics. Okay, and again, it was just put Stephen Hawking in there so that he could sell books. That's the only purpose of this nonsense. They have this black hole war, and the question is, what's it got to do with science? Why would anyone buy such a stupid book that deals with such a ridiculous subject? And this is how the war started, more or less. Okay, the black hole war. These two mental pygmies, right? Hawking suggested that black holes do not just capture matter and energy, but also obliterate the information contained within them. According to classical general relativity, all the information about the material that fell into the black hole would be lost along with it, contradicting quantum mechanics precept that information is conserved in physical processes. Information is conserved? What the hell these people study? These are physicists. They call themselves physicists, and they're talking about information. Susskind proposed that information, contrary to Hawking's assertion, is not lost in black hole, but rather somehow conserved. So we have information that is being conserved, I guess, in a little bottle, right? Susskind began to argue that there had to be a mechanism within the framework of physics that ensures informational continuity. Framework of physics. These people are saying that what they're talking about is physics. Is this physics? Does this information thinking have anything at all to do with physics? What are these people gaining their salaries on what basis? What are we paying them for? Okay, that's the question you should ask yourself. And here he says, came up with a holographic hypothesis, says the holographic principle emerged as a groundbreaking paradigm in theoretical physics, marking a significant shift in our understanding of the universe. The principle postulates that all the information contained within a volume of space can be represented as encoded on a boundary to that region, essentially suggesting that our three-dimensional world is a projection of two-dimensional data. This paradigm aligns with the way black hole entropy, which can be described by the area of the event horizon rather than the volume within, operates. Okay, so this is how black hole entropy operates. What is entropy? Just amount of disorder. And I'm not sure what these people are referring to, because everybody says out there that a black hole simply takes anything that crosses the event horizon, takes it directly to the singularity where it gets crushed out of existence. So how these people say that all this information is still somewhere in there and gets mapped onto the surface, I can imagine all the information on top of information on top of more information on the surface of the event horizon. Imagine putting all information one on top of the other. What kind of information is that? And he says, he suggested that this information isn't lost, but rather remains encoded in a two-dimensional form, adhering to the principles of quantum mechanics. If the universe itself operates holographically, every part of our universe could be storing information about the rest of the universe. Again, he thinks that our universe is encapsulated in some kind of ball, sphere, whatever, right? And that if we go to the edge of space-time, right, or the Big Bang, or whatever you want to call it, which is where we're at right now anyways, because they say that, space-time expands and all the galaxies are on the surface of space-time. They just get farther apart because the balloon is expanding, right, like polka dots, right, on a balloon. And so we're on the surface. That means all the information is encoded where we're at. Okay, all we have to do is go all around space-time, we'll find all the information that we want. Travel around space-time, split second, I guess, right? Okay, does this have any value whatsoever in physics? Well, we begin by saying that there's no such thing as a black hole. So if there's no such thing as a black hole, if a black hole is nonsense invented by the idiots, what is an idiot? Person with big ideas, right, of math. If there's no such thing, then all these people are wasting not only all their time developing these equations for absolute poppycock, for stuff that doesn't exist. Among them dark matter, dark energy, and so on. But how about the black hole? The black hole has been proven, right, beyond reasonable doubt, right? Has it been proven? Well, here it is. Here's the black hole. What is a black hole? Well, let's find out. Okay, black hole is simply a star that collapsed according to mathematics, right? It's a star that has collapsed gravitationally upon itself. Okay, so it crunches all the atoms that made up the star to the point where they all get crushed out of existence. They get all crushed out of existence. What is left is a concept, an abstract concept, which is comprised of two concepts. One is the singularity, which is the center of this thingy called the black hole, and its encapsulating cover, membrane, I guess, I don't know. It's a concept and known as the event horizon. And there you see it, that's it. Dot in the center covered by a concept known as the event horizon. Is this a physical object? Well, again, you would have to define what a physical object is for the purpose of physics to qualify a black hole as an object, as a thing. This is not a thing, this is a concept. Okay, and concepts are totally different than things. Okay, so this is where we start. This is what a black hole is, meaning so far we have nothing. We have a concept. And to add to this, we have the issue that if it's like they say that the black hole crushes all matter out of existence, it has no mass, because mass is the quantity of matter, or a measure of the quantity of matter. All matter has been crushed out of existence. We have zero matter. Guess how much mass we have? We have zero mass. So we have a concept that has zero mass. So far we have the definition of nothing. And that's what these people do. They study and make equations for absolutely nothing, literally. Okay, but let's concede. Okay, let's concede it's got mass, runaway mass, infinite mass, whatever you want to call it. I don't care. Put as much mass as you want inside a black hole. Okay, here it is. Okay, how does those kilograms, which is what mass is, right? Kilograms, how do they affect a star far away? That's billions of miles away. How does it flay the skin of the star alive, right? How does it force the star to move around the black hole? I mean, how do kilograms do it? I want to know the mechanism, right? And you could argue that it's done somewhat like this, where, the kilograms push downwards on space-time, which is the notion they have. So we have this infinite deep hole, right? And somehow that fishnet reaches all the way to the sun, to that star, right? And moves it around. But then how does this process flay the skin off of that star? I mean, do the gas molecules just roll along the fishnet to the black hole? Is that how it's done? I mean, what's the process? What's the mechanism? How do kilograms do these things? And of course, if the kilograms weigh the space-time downwards, we have Newtonian gravity. You have to explain why how the kilograms do that. And of course, they can't do that without invoking good old Newton. So, when they came up with this more accurate, as they call it, more precise equation, Newton's equation, trouncing Newton's equation, it turns out that in order to give their explanation, they have to bring Newton back. And they say, look, the sun weighs the canvas downwards, right? It should be really the other way around. The canvas should go downwards for whatever reason, and the sun has no other course but to fall into the hole, because it, the whole thing caved underneath it. But the way they explain it is in reverse. They say the sun, the mass of the sun, right? It's the mass, the kilograms, right? Push the canvas downwards. Could be upwards, but they always show it downwards because otherwise people would have too many questions. So it pushes the canvas downwards, right? And now that it pushed it downwards, the question then pops, why did it push it downwards? What forced the sun, the kilograms, right, to push the canvas downwards? Was there gravity pulling downwards, or was it kilograms pushing it? Which of the two is true? And so they never answer those questions. They just say, well, it just happens. That's the explanation for Einstein's equation, and that's the end of it. Don't ask more questions, right? And so, when you look at it, all these people like, Susskind and Witten, Ed Witten, what they're doing is they say, oh, these celebrities, these great mathematicians, they're such great minds. And, a mind is a terrible thing to waste, because what these idiots are doing is developing equations for inexistent stuff. And that's what they do all day. And you're paying them to do that. So, I like to put this in this context that, they're developing equations for dark unicorns and black leprechauns. That's what these people are doing. They develop all these equations and they say, look, we're doing science. This is not science. This is garbage. This is poppycock. It's got nothing to do with physics or with science. And the first thing that they should really do is show that there is such a thing as a black hole. And for that, they would have to define the word thing first, so we know what they're talking about when they say the word thing or object or whatever, right? Entity. Once they have that definition, then we can talk about things and determine whether a black hole qualifies as a thing. What is a black hole? A singularity, which is a concept, infinity, right? Where the laws of physics break down, whatever that means. And it's surrounded by an event horizon, which is a concept, which is like, the fire in a campfire. It's how far the heat reaches, right? And that's the surface of heat from the campfire, and that's more or less what an event horizon is. It's a surface of gravity surrounding the singularity, which is a point of infinite density, whatever that means, meaning it's zero-dimensional. And if it's zero-dimensional, it means all black holes are the same size because they all have infinite density. And it turns out that there's no mass in there because it crushed all matter out of existence, and mass is the quantity of matter. So we have the definition of nothing. And that's what all these people are working on. They're developing equations for absolutely nothing.